Now I am testing out my newest little component. Got off eBay for $17. A DC to DC buck converter. It's not a boost converter, it's a buck converter. It drops your DC input down to a lower DC output. So what I got here, I'll start at the grid. I'm just testing things. I have 120 volts from the grid. It goes into this transformer here at 9.9 ohms on this side. I'm not using the Variac, I'm just using this. So I'm dropping the voltage input to the rotovertor over here, eventually to the rotovertor, down to about 59 volts. And when I rectify it, it's DC. So I have 59 volts DC, which is good because this can only work at the most at 95 volts input. That's why I have this transformer. I need to get it below 95 volts, so it's at 59 volts. When I add a cap across the DC side of this full wave bridge rectifier, it raises it up to 85 volts. I've tried different size caps, and I also tried AC caps in parallel across the output, in series from the output in AC from this transformer. And I couldn't really get it much lower than that 85 volts with the cap on it. So I'm just leaving the cap off. And it's just the DC signal coming out of the full wave bridge, which is probably kind of humpy looking. But that's okay because it's working. And I'm getting 16 volts out of this DC to DC buck converter. And I twist this little potentiometer right here. It's supposed to be adjustable. And I twist that with a little flathead screwdriver and it doesn't do anything. It's like this is set and making 16 volts. So I don't know if it's broken or maybe it doesn't like the signal coming in, but regardless, it's doing what I want it to do, which is making a DC signal with enough amps to it and maybe a little bit over voltage to be feeding this inverter. Okay, so now I have the inverter going into the rotovertor with a 1 UF run cap. Oh shoot, I knocked something loose walking over here. It's this. Hold on a sec. Okay, I kicked some wires loose walking across my battlefield here. So now the rotoverter is running on this inverter. The inverter is powered on its DC side by this DC to DC buck converter at 16 volts, which is fed by this full wave bridge rectifier. The AC side of the full wave bridge rectifier comes from the output of this transformer which steps down the 120 volt AC from the grid to 59 volts from the grid in DC after it's rectified. So it's drawing from here, it's drawing from the grid 140 milliamps right now. And 120 volts. So that's the power consumption. Now, my grand viewer plan is to now take the run cap phase of the rotoverter, plug it into this side of the inverter, of the transformer, that feeds eventually the inverter after getting it kicked down with this buck converter. Buck converter does DC to DC. So I have that full wave bridge rectifier to give it some DC input. Like I was saying, I tried to kick it down some more. And also it doesn't seem to work, but it does what I wanted anyways, if I could adjust it. And so the idea is, instead of having the grid run in here, instead of having that go in here, I'm going to have this go in there, the run cap phase. Either in series or parallel, whatever it takes. And now, instead of, I am stepping down with a transformer, but the majority of the step down is happening with this buck converter, which is supposed to be 95% efficient. So it's working like this. I'm going to wait on doing the run cap phase because I'm doing something successful for once. I need to build up my confidence or whatever it takes. So I've been working on this house for a while. I need to put drywall in here, and I'm in the process of putting in electrical wires in the ceiling. Had a big mess right here. Got it all fixed up. I'm going to pull from the breaker box a couple 12 gauge wires and put them on the south wall where all the appliances are going to go, whatever. So that's my job for today here. And eventually you're going to get drywall up in here. So when I say I gotta go, that's why I gotta go, because I'm working over here and I'm kind of like taking a vacation working on my motors over here. And I'm probably going to need to move all this out of here pretty soon. So, okay, well, everybody, I hope sees what's going on. I'm using a buck booster to kick down the voltage to inverter level. The draw was 140 milliamps right now with the inverter and everything. And when I ran this just now with the 1 UF run cap, it's 80 milliamps. So it's taken about 60 milliamps loss from all this junk. This transformer, the full-way grid, the buck converter, the inverter, and maybe if I put some AC caps here and there, I could improve that. But like I said, next thing is take this circuit where it plugs to the grid and plug it to the run cap base. I don't really want to do it right now. I have a feeling it's going to fail and I'll feel lousy about it. So I'm going to wait on this and kind of build up some positive energy before I try it. Okay, one more thing, I guess. Warren Keeler said that his stat power inverter, when it got 16 volts, it blew out. So I should, before I try these, because these are twice as efficient as these, if I try these out, I'm going to need to put a voltage regulator on the end of this, right here, the output of the buck converter. Bring it down to like 14, make sure, or something. So that's about it. Okay, thanks for watching.